Good morning, everyone. Let's try that again. Good morning, everyone. Perfect. We are here to talk about this. Not only what it is, but how we do it internally at Microsoft. What I want to start with is a visual aid, something that will help put you in my mindset, how I see your company transforming before and after you implement DevOps. So I'm going to show you a video, and we'll talk about it after.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. The tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
When I saw that video, I was like, that's it. That's what every corporation should be trying to do. Go from swinging a hammer to actually changing all 4 tires in a blink of an eye. And I'm extremely active on Twitter, so what I did is I tweeted that and I said, this is DevOps before and after. Most of the people got what I was trying to say, but a couple people said there was no value in the second pit stop at all. I'm thinking to myself, how is this possible? One person said, look at how many more people there are. Of course they went faster. They didn't really solve any problems there. And then one person pointed out they didn't even refuel the car. There was no value. So I'm sitting in my office, and I'm reading these, and I work at home. And clearly I'm having some type of physical reaction because my wife walks into my office and says, what's wrong with you? Like, why are you mumbling to yourself? Like, they just don't get it. How do they not understand that this is an amazing analogy for DevOps? I should write a blog post. She's like, yeah, you should write a blog post. So I did. There's a huge blog post that explains why this is an amazing analogy. But what we're going to do is we're going to address these 2 individuals here. Now, I've blurred their faces because they might be standing right next to you. But if you want to know who these 2 knuckleheads are, I didn't delete the tweet. You can actually go find them, right? But let's address these 2 right now. There's an increase in the number of people. I started my career back at a company called Compact Computers. Does anyone remember Compact Computers? All right, quick, look around. All these people are old, right? That's where I started my career, at Compact Computers. And I remember when I, Donovan Brown, was done with software, I would take my floppy disk or my thumb drive if I was really, really lucky, and I'd walk inside of our server room. There was just rack after rack of ProLiant servers. And I, Donovan Brown, would pull out a tray, type in my keyboard, and the machine would say, welcome, Donovan Brown. I had complete control over that machine. I would change registry settings. I would move files, delete files, do whatever I needed to. Trust me, I was swinging a hammer at a ProLiant server trying to make it do whatever I needed it to do. Once I got all my files copied, and as soon as the IT pro turned their back, you run out of the room as fast as you can. Because as long as they didn't see me do that, it was their fault, not mine. It was awesome, right? All the glory, none of the consequences. Beat the server to death, run out of the room as fast as I want. That was me and a server. Try doing that today. Chances are you don't even know where the servers are. You definitely do not have admin access to those servers. Dev is involved. Ops is involved. QA is involved. Auditing, regulators, program management, the janitor, everybody's involved. Right? They all want to have their hands in actually deploying software. So on that level alone, this analogy works. There are more people involved today than ever before in deploying software. But what I think is really interesting is when I saw this for the first time, I didn't see those as people. I saw them as continuous integration, continuous delivery, infrastructure as code, all the DevOps best practices that we string together to make it easier for us to deploy software faster. They weren't people to me. And what I know is interesting is that the more I look at this, the more I see parallels to what we do with DevOps. For example, if you look in the upper right-hand corner, those two individuals never move. They are looking at a 3-second pit stop, trying to figure out how they can make it a 2.5-second pit stop later. And that's what you should be doing with every change you make to your pipeline. Measure now, make a change, measure it again. Did that improve something or not? How can we go faster the next time? How many of you have attempted to build a DevOps pipeline? Anyone? I bet the first time you did that, it didn't go quite the way you expected it to. And what's your first knee-jerk reaction? How can I roll this back? Right? How do I have safeguards to protect against this? Look very closely at the back of the car where the person has a jack. At some point, I have to believe that that jack failed. Why? Because the person behind him has a jack too. You know what? Look at all the people using the impact wrenches. At some point, those impact wrenches had to fail because look at their feet. There's one behind each of them. There's backups. There's redundancy built inside this particular process. Right now, security is really, really hot. They even call it DevSecOps. Look at the center of the car. Those two individuals holding the car are just securing it on the jack stands. DevSecOps right there in front of us. The more I see this, the more I see parallels about what we're doing today. If you built a pipeline 10 years ago, the tools we use today are better than they were. 50 years ago, they were using a hammer. Now they use an impact wrench. You should be doing the exact same thing when you're implementing DevOps in your organizations. Now let's talk about filling the car. I've always been taught that you fix what hurts most first. Was refilling the car the thing that hurt the most? No. They were done halfway through. If we refueled the car at the same rate in 2013 that we did in this video, we still would have been done in half the time. Focus on what hurts most. So in my mind, what happened here was they said, man, if we could change those tires faster, we'd get out of the pits faster. So they realized that they could change the tires now, let's say, in 10 seconds. Now all of a sudden, for 20 additional seconds, the guy's sitting there holding the gas. Now we got to go fix that problem. And what they did is they shifted left innovation. They shifted left technology so that the car can go further on less fuel. Because trust me, if the car needed fuel to finish the race, they would have put fuel in the car. They completely eliminated the bottleneck altogether. Put another way, if it hurts, do it more often. That which we persist in doing becomes easier, not because the task itself becomes easier, but our ability to perform it improves. That's Emerson who said that. And it applies to what we do in DevOps. If you only deploy your code twice a year and it's a nightmare, who cares? It's only twice a year. Do that deployment every day. See if you don't automate it. See if you don't figure out ways that you can go from swinging a hammer to doing stuff like this. And this is exactly what we did inside of Microsoft. We took a process that took us 3 years, and we reduced it down to a process that we do every 3 weeks. And actually, we ship software twice a day. I showed you that video and kind of gave you that illustration so that you can understand what I was thinking about when Microsoft asked me, Donovan, what is DevOps? It took me 30 days to write the sentence I'm about to show you. I labored over all of my experience as a developer. I reflected on my career at Microsoft, and when I was done, I came up with this sentence. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word is value. DevOps is not about shipping features faster. DevOps is not about changing software. DevOps is about continuously delivering value. Why is value so important? Because both dev and ops can help deliver value. If all I talked about was changing software, the operations people would think I'm not talking to them, but I am talking to them. I'm talking to everyone in your organization who has a vested interest in this software being successful, this application being successful, this solution delivering value. I speak to our customers all over the world. Spoke to some yesterday. I was in Sweden last week, spoke to them there as well. And what I find out is they say, man, Donovan, for some reason, our dev and our ops team seem to hate each other. Like, really? Like, yeah, they do not like each other. They're always pointing fingers at each other. Can you explain to me why this is happening? I'm like, first, let me ask you a few questions. How do you incentivize and reward your operations teams? Well, it's about uptime, keeping the lights on, keeping our infrastructure healthy. I'm like, okay, that makes sense. I'd expect that. How do you incentivize your developers? It's about adding features and adding value and pushing it to our pipeline. I'm like, okay, interesting. Do you realize the easiest way to keep the lights on a server on when they're already on is not to change it? Right? A server that is healthy will stay healthy if you don't change it. But you just told your developers to attack the servers and change them as much as you possibly can. And I'm only going to reward the operations teams if they stop you from doing that. You want to know why they fight against each other? Because you told them to. But if we change the conversation and say it's not about uptime, it's not about features, it's about value. And you both have to be able to show that you delivered value to our end users, they will naturally work together. Do I have to change my software to deliver value? No. In the United States, we have this day called Black Friday. It happens after Thanksgiving. It is the heaviest shopping day in the world, followed by Cyber Monday, another extremely heavy shopping day. People are going to come to your websites if you're an e-commerce site. Do I have to change a single line of my software to deliver value? I'll tell you right now, the answer is no. I can scale up or scale out my infrastructure, keep my response times down, and sustain more simultaneous users, sell more material, and actually deliver value as an operations person, as a developer, as a team member. That's why we focus on the word value and not software. The hardest part of this is the people, right? You're all hearing this, and I hope you go back to work energized and excited about doing DevOps right. You're going to find all these problems, and you're going to rub a little DevOps on it and make it better. But what's going to be the problem is that the people who aren't standing next to you that work with you, the people who have been doing it the same way for 30 years, don't see a problem with what they're doing, so they're just going to keep doing it the way they've always been doing it. So you got to get your people to understand that DevOps is not an option. It's not a nice to have. It's fundamentally important. You either implement DevOps or you lose. Just go ask Blockbuster what Netflix did to them. Just go ask the taxi industry what Uber's doing to them right now. Just go ask Barnes & Noble and any other bookstore what Amazon is doing to them right now. You either implement DevOps or you lose. So we realized that at Microsoft, and we had a product that we had to go back in and make better. I believe it all started with this man here. This is our CEO, Satya Nadella. He is an engineer by trade, made his way all the way up through Microsoft, and now runs the whole thing. When I joined Microsoft, I was a seller. It was my job to come and sell you Team Foundation Server. Anyone use Team Foundation Server 2005? I'm sorry about that. But it was my job to come and install it for you. And I would install it, and I'd make you real happy with it, and then I'd leave and go do it somewhere else. And then I got recruited at Microsoft to go and sell this product. And I was the technical seller. So the salesman had already been in there, promised you the world, told you how much it was going to cost. And right before you wrote that big giant check, you're like, oh, hold up. I don't believe it can do all the stuff you just said. And then I'd fly in like a superhero, do some crazy technical demo, and then you'd be like, all right, now we believe you. But the funny thing is that after the demo, no matter how good the demo went, if you looked under the table, my leg was trembling like mad. Why? Because I was always afraid they were going to say, so Donovan, how does Microsoft use TFS? Dirty little secret. Till recently, we didn't. Till this guy shows up. He's speaking at a conference called Tech Ready. It's an internal conference that we have at Microsoft. It was the first time I was ever going to get to see him speak. I'm sitting dead center, front row, so excited. He comes out and he says these words I'll never forget because it hit me in the chest. He said, we have to stop living this fake life where we would write software for others that we would not use ourselves. I was like, wow, if you make this happen, I no longer will fear if they're going to ask me if we use TFS. I'm going to lead with the fact that we actually use TFS. And selling this stuff is going to be a piece of cake. And that's exactly what we've been doing. The Azure DevOps team uses Azure DevOps to create Azure DevOps. The Windows team uses Azure DevOps to create Windows, Xbox, Bing, HoloLens. Name a team, they're using this system. We call it the One Engineering System. And it's the engineering system that everyone in our company is going to use. If you're not there yet, you've been mandated to get there. And everyone is coming. And that's what we're trying to do. The services that we're going to be talking about are these. The team that I am going to be talking about is called the Azure DevOps team, and they were responsible for these 5 services that we collectively call Azure DevOps. The name is horrible. So you don't have to come up to me and tell me how bad the name is. I agree with you. Horrible name, because it works for more than just Azure. Right? It does all sorts of things. But what I want to show really quickly is that it's everything that you need to turn an idea into a working piece of software. You get an idea, you got to have a place where you can track it, where you can plan it. That's Azure Boards. You got to have source code that you got to start checking in places. That's Azure Repos. Once you start getting some check-ins, you're going to want CI builds and CD. You're going to get that from pipelines. Your manual testers are going to want to get involved. They have test plans. You got artifacts that you're producing. We'll store those for you too. Everything that you need. This is produced by about 50 feature teams, which we'll talk about the anatomy of, all across the world. Some are in Hyderabad, India, Raleigh, North Carolina, Redmond, Washington, and San Francisco, California. 50 of them, all merging into master every single day, doing on average 600 pull requests a day. How in the world do we do that? That's what we're going to go talk about. Now, I said we're using this internally, and these are just some numbers. These are only internal numbers. These are not our external customers. We do about 6.3 million builds per month. We do 163,000 deployments a day of just Microsoft stuff. When you start to extrapolate this beyond with all our external customers, it's just an amazing experience. But I just wanted to prove to you that when we say we're dogfooding this stuff, we're not bluffing. We actually use the products that we build. You remember 2005. You already raised your hands. It was a rough time. But what we said to ourselves is like, all right, we know how to make this better. We had this cool crystal ball at Microsoft that tells us what everyone wants 3 years from now. So we looked at the crystal ball and said, we know exactly what they want. Let's put our heads in the sand, ignore everything that's happening in the industry, and 3 years from now, give you 2008. Wasn't 2008 so much better? No. Not only was it not better, it was behind all of the industry leaders. It was behind Jira, behind GitHub, behind Jenkins. It was behind everyone. We were like, all right, 3 years? 3 years is too long to put our heads in the stand. But 2 years. If we're only gone for 2 years, we'll nail it perfectly. 2010, that was the first time we did 2 years. 2012, maybe 2 years is too long. But if we're only gone for 1 year, that's the sweet spot. 1 year will make it, right? Nope, further behind than ever. Then all of a sudden, Satya shows up. We now have to start using it internally. And we didn't go back to 2 years. We started shipping updates every 3 months, and we have not stopped yet. If you're using our on-prem product today, we will give you an update every 3 months with new features, with new performance enhancement, bug fixes, the whole 9 yards. That wasn't fast enough for us. But that's as fast as our customers who are on-prem can even consume our updates. So we said, let's host this in the cloud as well, and we're going to update that every 3 weeks. If you're using Azure DevOps, you're getting new features every 3 weeks. It gets even better than that. If you're using Azure DevOps and there's a bug, we're shipping those twice a day. We call them trains. As long as your code is in the master branch before that train leaves, your code will be deployed out into production in the next train that goes out twice a day. Those are only for bug fixes and enhancements, no new features. New features only come out every 3 weeks, and we'll talk about that a little bit more as well. We are an entirely agile team. We have been blessed through the Church of Scrum. This is what we believe in. And if you're doing Agile or Scrum, you should know that you should have a definition of done. And I just wanted to share with you what the DoD is for the team that produces the 5 services that I just showed you. Now, several times today, you're going to hear me say we and us and Microsoft, but I want to be very specific. I am only talking about the team that builds the services I just showed you. This definition of done is not the same one for Bing, for Xbox, for HoloLens, for Office, for Windows. This is the team that actually builds Azure DevOps itself. If you're new to Agile or you're new to Scrum, I would not start with a definition of done that is this mature. This is hands down one of the most mature definitions of done I've ever seen. It does not say your code complete. It doesn't mean that you're feature complete. It means that it's running in production, sending telemetry home that verifies why we even wrote the code in the first place. That's an amazing DoD. I hope we're not done yet. Because are you really done with a piece of software that's running in production? No. You're still monitoring it. You're still enhancing it. You're still writing bug fixes for it. You're really not done. We need to add one more paragraph, one more sentence to this that says, when it is replaced by its next feature, when it's replaced by the feature that makes this one obsolete. So we're going to actually pull that code out of the code base and replace it with something else. That's when you're really done with that piece of software. And what we're doing now is we're just maturing this DoD every time we go through a retrospective to find out how we can make it tighter next time. I just wanted to share this with you. Do not start here. You will get discouraged very, very quickly because getting here took us 8 years. All right. How is our teams built? Historically, we were a program management group, a group of developers, and a group of testers. Our program managers would come up with all these wild ideas of what we should do and what the features should be 3 years from now. We would hand all this code over to our dev team. The dev teams would make it code complete. They didn't think testing was important because we had a test team. We wanted to make sure they had something to do. So we didn't write any tests. And when we throw these black boxes of code over the wall, go have a pizza party and pat ourselves on the back for making a milestone, and as soon as we start partying and we're all happy, we get really sad with this just mountain of technical debt that just comes pouring down upon us like a waterfall from the QA team who's found all these bugs and there was stuff that we had just delivered. And then what we would do is just bug bash it. And then realize this is taking way too long. And we also realized that our testers were taking longer and longer to write the automated UI tests. And Buck Hodges, who's the director of engineering, went over and said, "What's taking so long? This didn't used to take you this long before." He says, "Well, we're trying to get high levels of code coverage. And to do that, we have to get into every nook and cranny of the code. And the way that the code is actually designed makes it very difficult for us to get to all those nooks and crannies." Like, well, then why don't you just rewrite it? So hold up. We're the test team. Like, yeah, we're engineers and we're automation engineers, so we know how to write code, but that's not our job. We're going to let the developers do that. It's like, yeah, but that's just a waste of time. He says, okay, this is what we're going to do. He realized that if the developer who wrote the code was responsible for testing the code and found the code difficult to test, they would simply rewrite the code and make it easier to test. Only logical option. So why don't we just combine the testing team and the development team into one team? You are now responsible for quality from time zero. Unit tests become more important because you can't rely on the automation UI tests. UI tests, by the way, are very expensive, very slow, and very fragile. So why don't we start re-architecting our system such that we're thinking about testing up front so that we're actually designing the quality into the product instead of trying to bolt it on after. Oh, no, yeah, and by the way, since we're moving to the cloud, we better bring the ops team with us so they understand what we're going to be doing inside of Azure, what capacity that we have, and how we're going to do infrastructure as code to get everything deployed in a very repeatable way. One of the things that I want to make sure that you understand very clearly is that being good at DevOps is not just about finding the right tools and products to put in place. We've had to re-architect our system multiple times to make sure that we can move at the speed in which we wanted to move. It is not all about just making sure you have the right build definition. Really look at the problem that you're trying to solve and go ahead and admit that maybe we made a mistake and we need to go back and re-architect that. We've done that over and over again, okay? Now, another thing that's really important is, again, we are Scrum teams. We create what we call feature teams, and those feature teams are directly connected to the customers that they serve. Gone are the ivory tower days of Microsoft. If you want to get a hold of us, you can actually do that. I have my Twitter handle at the corner of every one of these slides. If you tweet at me, I will answer you. And I'm going to give you a hashtag that you can use later that's even more powerful than that, because there's a lot of us at Microsoft that are monitoring that hashtag, and we'll all come running if we see it. When I say that we are connected to our customers, again, I am not bluffing. If you want to talk to us, you can actually go directly inside the product itself. Use your avatar to get to a menu that will allow you to send suggestions. Those suggestions can very well end up being new features and products that we produce. You can go to our developer community. And this is a lot of fun if you have a lot of Twitter followers. I remember I went to one of the Azure DevOps people. I said, I think this would be a really good idea. Like, I don't think you're right. Like, whatever, I'm going to go put it in the developer community. He's like, yeah, Donovan, but we're probably never going to do it. I bet it's not popular. I'm like, that's funny, because I have 14,000 followers on Twitter. I bet you I can make this popular. Hey, guys, I think this is cool. Boom, top of the list, right? So use Twitter to your advantage. You want a feature that you want in our product, go tell your buddies about it and have them voted up there. And believe it or not, it will end up on our product backlog. Once it's there, you can also go to Stack Overflow. Once the feature's out, you might have some questions over it. We are monitoring Stack Overflow like crazy to make sure that we're where you need to be so that we can actually help you better. Again, we will ask you periodically, hey, how likely are you to recommend this product to one of your peers, and give us some suggestions on how we can make it better or make that suggestion even easier for you to give. And then finally, we actually go back and we track telemetry. We collect about 7 terabytes of telemetry a day on Azure DevOps. We collect so much telemetry, we had to write a custom product just to comb across it, and then we actually productize that product as well, and now we sell it to you as well. But this is how we know if you're using it. This is how we know if we delivered value. This is how we know if the system is actually healthy or not. And then again, I said Twitter. This is just an example of a tweet. There's a fun story where it's called App Center now. It used to be called Mobile Center. I got a tweet saying, hey, Donovan, last night my builds were working fine. I wake up this morning, they're not working. I didn't change anything. Is there something wrong? Like, that's a good question. Hold on. Hey, Thomas, who's the guy who invented Hockey App and was responsible for Mobile Center, I was like, hey, is something wrong with the builds? He's like, let me go check. 3 hours later, he's like, try your build again. Imagine that. You reach out to Microsoft, and 3 hours later, we have pushed a hot fix for you specifically to make sure that your builds are working again. That's the Microsoft that you're talking to now. not the Microsoft that you used to know. So our teams are co-located. Now, this is not to say that you cannot be successful with Agile or Scrum with a remote team. You can. But we find it's very efficient for us to actually have everyone co-located. Do we have any Microsoft MVPs in the house today? A few of you? So if you're a Microsoft MVP, we invite you to Redmond every year. You can actually go find this exact room. This room is in Building 18. The people will be different because we kind of rotated them around so they're not always looking out the same windows, but that room exists in Building 18, and there will be a feature team in that room working on a particular feature of Azure DevOps. The reason that we like this is because it's so efficient. When it's time for your daily stand-up, you know what you do? You stand up because everyone's within earshot. You answer the 3 questions, you sit your butt back down, you get right back to work again. If I happen to have a problem with the API that you've just written, I don't try to find you on Slack. I don't try to schedule a meeting. I just swivel my chair. You and I have a conversation, and we both get back to work again. It makes us really, really efficient. Sometimes you don't agree with me on the change, and we don't want to distract everyone. So we have these 2 rooms outside of this room that have doors on them so that we can have a more, spirited debate on which one of us is right. And then we can also have conferencing software in there, whiteboards in there. It's a great place for you to go off and do some brainstorming or also communicate with a team that might be in Hyderabad, India, that you actually have to coordinate with. One of the things I love about these rooms is that every room was unique. Every room has their own culture. For example, if you look here, the gentleman in dead center, he has a Coke can on his desk and he's wearing headphones. In some rooms, that's permitted. In other rooms, it is not permitted. Some rooms you can eat, some rooms you can't eat. I always find it interesting that they took a picture of this room and didn't take a picture of the room that I was in. So I remember the day that I was rolling my desk into my room, I was having a lot of trouble rolling it because it kept hitting stuff on the floor. I'm like, what are these things on the floor? So I look down and I reach over and I pick one of them up and I'm like, this looks like a Nerf bullet. Like, what's going on here? Like a scary movie, I look up and scan everyone's desk and realize everyone has a gun in this room. And then all of a sudden I saw why that happened. The reason why is because sometimes the developers just had to blow off steam. And next thing you know, it looked like war games in there, just Nerf bullets going everywhere. And if you didn't have a gun, you're the one getting shot, right? So everyone had a gun, but that was so cool that that room had its own culture. And that's exactly how that team liked to work. Now, you might not like getting shot, so what we do is we allow you to switch teams, which I'll talk about in just a second as well. But what I want to talk about here is that when you adopt DevOps for the first time, actually more specifically Agile, a lot of us historically have written software in layers. You do the database first, you do the middle tier, and then you finally bolt on the front end. That could be months before you actually see progress. And it also means interacting with multiple teams, and those interactions and distractions slow you down. So what we realize is that each one of those feature teams I just showed you, they own every layer of their feature. They own the database, they own the middle tier, and they own the front end. So instead of cutting it horizontally, we've now positioned our teams to cut through an entire feature vertically. They own everything. That reduces, but does not eliminate, the need to coordinate with other teams, and I'll talk about how we coordinate with some of our other teams as well. So I kind of alluded to the fact that we let you leave. I've been a developer since the early 90s. I remember the software that I started writing at Compaq Computers was the software I was writing until the day I left Compaq Computers. And after a while, you just don't want to see that code anymore. Right? You're just like, man, if I have to see these same lines of code again, I'm just going to go crazy. I'm sick of looking at this code. So what we allow our engineers to do is every 12 to 18 months, pick another team. Right? You can go to any of the other teams that you want to. That way it keeps it fresh for you. We get to actually have the cross-pollination of experiences and diverse opinions on those teams. But what's really interesting is about 80% of the people choose to go back to the team that they were already on. They like the culture. They like the technology. Or they already bought the gun, whatever the case might be, right? But what I love is the 20% who are brave enough to go somewhere else. Because there, again, we're getting that cross-pollination. We're actually having knowledge transfer, and we're having diverse perspectives inside each one of the teams. So this is a really cool thing that we do inside of Microsoft to make sure we keep it fresh for our engineers, and no one gets just bored and feels like they're on a death march, which is great. We run 3-week sprints inside of Microsoft. And I say Microsoft again, I actually just mean the Azure DevOps team. Every team has their own. If you're new to Agile or new to Scrum, there is a process that you go through to determine what your sprint length should be. It should be anywhere from 1 to 4 weeks. If it's longer than 4 weeks, you're faking it. Right? Do not go beyond 4 weeks. You're basically just trying to say that you're not waterfall when you still are, right? Because you're not able to break that way of thinking. We chose 3 weeks. And the interesting thing is I was not there when 3 weeks was chosen, but as a Scrum Master, I know what kind of questions I would ask, but I asked Aaron Bjork, who used to run all of our work item tracking, so how did you get the 3 weeks? So that's an interesting question, Donovan. We call it a Goldilocks principle. Like, really? Like the fairy tale? Like little child things? Like, yeah. We tried 4 weeks and it felt too big. We tried 2 weeks and it felt too small. But when we got to 3 weeks, it felt just right. Because if you've done it before, there's a lot of rituals involved. And when you're doing a really short sprint, you're in so many meetings, you feel like you're in more meetings than you are actually developing. But when you get a sprint that's 4 weeks long, you're guessing what you're going to get done in that 4th week. And you never quite get it anyway, so why are we wasting time trying to plan and estimate stuff that we're probably never going to get to anyway? 3 weeks hit that perfect balance for us, to where the amount of meetings and the amount of development and our accuracy in estimating were all perfect. So we've been running at 3-week sprints for a long, long time now. So let's break this down a little bit. It starts off basically with a sprint email. And this email goes out and says, this is what we plan to do for the next 3 weeks. And then afterwards, we get another email that says, this is what we got done. And inside of it is a 3 to 5 minute video showing you exactly what got done. So it's like you were able to sit in all 50 of these sprint reviews. Now, if you do the math real quick, how many emails is that? It's 100 of them. Every 3 weeks on the exact same day. Email rules are really important when you get that many emails. And it's too much email to actually read. So what we've done is we've gone ahead and actually modified this process a little bit as well. Instead of having 50 people email us, what we have now is their manager. So you can imagine every 5 to 6 teams basically accrues to one particular manager. They're all related to each other. For example, there's 5 teams on work item tracking. There's probably 5 or 6 teams on version control. And their manager now sends a single email. This process that we had worked great when there was only 12 teams, even when it was only 20 teams. But when it got up to 50 teams, this simply did not scale anymore. Why am I telling you this? Because we are also continuing to learn. The DevOps journey is one that you start and there is no end. You're constantly trying to figure out ways that you can go faster than you did yesterday. And we're still learning at Microsoft as well. So instead of getting 50 emails, we get far less. We raise it up a level to the group program manager, who now writes the very similar email that has both what we're going to do and what we got done in it. So that drastically reduced it in half. And now we're getting 5 teams worth of information, so they're much denser emails. Still has a 3 to 5 minute video in it showing all the value that was added by the team in the previous sprint. Fantastic way. Again, look at what you're doing, find ways that you can go faster. That's exactly what we're doing inside of Microsoft as well. Let's talk about planning a little bit. This is something else that we also changed. We used to plan 18 months in advance, and now we've gone down to only planning a year in advance. Again, some of the stuff that we would try to get to 18 months from now simply wasn't relevant anymore. If you were to look back at what we had planned 18 months ago, and we'd only done about 60% of that, that was actually a success. Because the world changes, you have to reevaluate it. It wasn't that we said we're going to do this until we're done, and 18 months from now made sure we had checked all the boxes. We said this is what we believe needs to be done 18 months from now, and if the world changes, we'll adjust as we should. But now we use OKRs, and OKRs are usually done quarterly, so it really makes sense for us to go ahead and move down to a 12-month season. We do 6-month semesters. Semesters are basically, they're bookended by big events. We used to have Build and Connect. One was in about April, May timeframe, and the other one was in November. And basically what we're trying to say is, what do we want Scott Guthrie to get on stage and announce? And then we basically put that in one of the 6-month buckets. And then what do we want him to announce at the next event? We'd put that in the next 6-month bucket. And then we would basically drive towards that so that he could announce those big things for us. And now because we're using OKRs, we have quarterly reviews as well. And then we basically sprint every 3 weeks. Now, one of the things that I don't have on this slide, which is a really interesting meeting, is every 3 sprints or every 9 weeks, the teams would come together that were related to each other and sort of have a scrum of scrums of sorts. And I remember when Aaron Bjork was here, I asked him, could I please sit in on one of your teams doing that? He's like, sure. They were all in Raleigh, North Carolina. I happen to live in Houston, Texas. He phoned me in so that I could actually listen in. And it was really interesting. They're all having pizza. And one of the engineers starts talking and he says, so for the next 9 weeks, what we intend to do is build this widget. And this widget's going to allow our customers to do X, Y, and Z. After they finished speaking, another engineer said, hey, that's interesting. Sounds like one of my team members just wrote that exact same thing. So why don't you have your engineer talk to my engineer, and let's see if we can reuse them or not. Lo and behold, they could. Had they not had that meeting, they would have 2 widgets doing the exact same thing, carrying their own technical debt. So you got to find those opportunities for your teams to collaborate to make sure that they're actually being able to do code reuse as well. Quality is something that's really, really important. Again, how many developers do I have? Okay, so everyone knows what a code freeze is, right? Code complete. That's basically a nice way of saying, please stop typing. Because if you keep typing, you keep creating bugs, and we got to stop you so that we can actually go count the bugs you already have. And then what we would do is we take this black box of code, throw it over the fence, distract you with pizza and ice cream and pats on the back, while the QA team goes off and counts all the bugs that you've gotten. And then again, it would just come raining down upon you as what we call technical debt. You would do a bug bash, and then you would ship it in whatever quality or state it was in when you were done with your bug bash. This is a horrible, horrible way of writing software. What we wanted to do was streamline this a little bit. Again, enter Buck Hodges, director of engineering. He says, I always want to be 1 week away from shipping. He did some math and realized that on average, each one of my engineers can clear about a bug a day. So if I didn't carry more than 5 bugs per engineer at any given time, I should be able to come in on Monday and say, I want to ship on Friday. And if you did nothing but pay down the technical debt, we should be ready to ship. Made perfect sense. So he wanted to go from this to something that looked more like this. 5 was a little bit of aggressive, so what it ended up doing was changing that number to 4. He just did the math, and we track this very closely. If you find out that you have more than 4 bugs per engineer at any point in time during your sprint, someone has to stop what they're doing and go pay down that technical debt. Technical debt is like financial debt. The longer you let it linger, the more expensive it is. So you got to start paying it down as soon as you can. How do I know if I have this technical debt? That means I'm also testing it sooner. Remember, we didn't used to test at all. But for me to be able to track this number means I have to be running unit tests. I have to be making sure that the code is actually able to pass or fail something that gives me the indication or indicator that I am either within or not within this particular boundary. We track this pretty closely at our company. We call it the bug bar. And on the street, let me zoom in a little bit for you. It basically gives you an opportunity to see who's above and who below that particular bug bar. I cannot say or stress what I'm about to say hard enough. You cannot punish your people for these numbers. I'm going to let that sink in, and I'm going to say it again. You cannot punish your people for these numbers. These numbers are for you to inspect and adapt. If I get in trouble because that number is a 6, trust me, it'll never be a 6 again. Even if it's supposed to be 6. Because I'm going to game the system because I don't want to get in trouble. But if you do what you're supposed to do with these numbers, which is wonder, why are they at 6? Let me go have a conversation with the team and find out if they were just stressed out, if it was more technical than they thought. Do they need more additional training? Or do they need additional capacity? As a manager at Microsoft, when my team fails to do this, that is a failure on me, not my team, because I didn't enable and empower my team to stay below that number. So please do not punish people for these, or these numbers become useless. It's an opportunity for you to inspect and adapt your process and move it forward. We don't only count the bugs, we also count some other things, which I'll show you here in just a second. We measure lots of stuff. Remember, I said we get 7 terabytes of telemetry a day. It's more important to not only know what you want to measure, but it's really important to know what you don't want to measure. Don't waste time looking at their old estimates and seeing how good or bad they were. Trust me, all their old estimates were wrong. That's why they're called estimates. None of us are good at it. Don't worry about how many lines of code the person developed. I remember having software, one of the cool features was, it would actually count how many lines of code you wrote. And we would write all kinds of lines of code, even if they didn't add value, because that was the metric that we were being graded on. Know what you need to measure, and more importantly, know what you don't need to measure. Whenever people talk about Donovan, you say measuring and telemetry is so important, where am I supposed to put it? Do not just scatter it everywhere. You should have a question that you want to answer, and then you put the telemetry in the appropriate places to be able to answer that question. And then when you get a new question, you adjust your telemetry to answer that one as well. But you don't just go scattering it around, because then you end up having so much telemetry, you can't make sense of it. And we're already collecting 7 terabytes of it, and that's stuff we need to know. Just imagine if we were just peppering it around everywhere for stuff we didn't even need to know. So it's really important. Know what you need to measure, and just as importantly, what you don't need to measure. This is our engineering scorecard. We have a mantra at Microsoft. If you wrote it, you run it. Gone are the days of Donovan Brown installing software on a server, running out of the room, and sleeping well at night as the server burns to the ground. Right? Software doesn't work. I'm at home asleep. Some poor IT person is in there fighting fires, on the phone with IT, on the phone with a customer, trying to solve the problem, finally fixes the problem for the customer and knows it's a bug, logs a bug, and I wake up all rested and refreshed. The next morning, wiping the sleep from my eyes, I get an email notification, you have a new bug. Maybe I fix it, maybe I don't, right? Because it's more fun to write bugs than to fix bugs, so maybe I write some more bugs today. And that poor person fights the same fire tonight and the night after and the night after until I get bored enough to where I go and fix the problem. Because why? No consequences for my actions. I make bad decisions, someone else pays the consequences. It was awesome, right? But it's a horrible way for the other person to live. So what we do at Microsoft, if Azure DevOps goes down or any feature stops working, not only do the operations people get up, the engineer that wrote that code gets woken up as well. Period. End of discussion, get up. Guess what that does to quality? Because you want to sleep at night. You start writing really, really good code. You start writing lots and lots of unit tests. You start making sure that code works the way it's supposed to because you want to sleep at night. If I get woken up in the middle of the night because of a page that I wrote that tried to cast first name to an integer and crashed, I'm going to be doing try parse for the rest of my life, right? You're going to start writing better code because you don't want to have to freaking wake up. Being on call at Microsoft is no joke. You are on call for an entire week, and that week, you're not going to your child's recitals, you're not taking your wife out to dinner, you are responsible for that SAW machine is what we call it. It's a air-gapped, super secure laptop with the only thing that has access to Azure DevOps. And when we have an LSI, you have 5 minutes during business hours and 15 minutes if it's 3 o'clock in the morning to get your butt on a bridge and start troubleshooting that for our customers. It's amazingly intense. That's why you only have to do it for a week, and then you basically get to rest for 3 or 4 months, and then all of a sudden, it's your turn again. And you have to be on call. Again, quality is amazingly good when people want to sleep at night. And what we do is we measure how good we are at that. How long did it take us to find the problem and even identify it? Did it come from an email, or did it come from our telemetry? If it did not come from our telemetry, what telemetry were we missing that can then have identified that for us and allow us to fix that before our customers even know? After we identified it, how long did it take us to bring the system back to a point to where it was at least usable by our customers? How long did it take us to mitigate that problem? Now that we mitigated the problem, we have to go back and do what we call root cause analysis. Sometimes people call it the 5 whys. It's basically saying, what was the problem, the root problem, so that we can go fix it. If you have a memory leak, a solution is not putting a timer that reboots the server every hour, right? That is not a fix. You didn't fix anything. But what you got to do is go identify where that leak is, what the problem is, and fix it permanently. And what we do is we identify it, and then we put work items in the backlogs of the teams that are affected, and that is the top priority for them the very next sprint. Go fix this thing. What's even worse, I don't know if it's worse, but it really attacks your pride as a developer. Back when Brian Harry ran everything, and we still do this today, it's run now by Buck Hodges. Every LSI we have, or live site incident, is completely documented and completely transparent, and we blog the entire incident, minute by minute, how we found out, what we did, the apology we're giving you, and the plan that we have to make sure that this never happens to you again. A very prideful engineer does not like having to read an email or a blog post about a bug that was the result of their actions. It's a really good motivator for us to make sure that our bosses and our leadership never have to write those type of blog posts again. Some of them are out of our control. Wasn't too long ago, Mother Nature decided she didn't like our data center in San Antonio. So she struck it with lightning. Took the whole freaking thing down. We learned a lot from that one, because one of them was an embarrassing lesson. So we have this website for Azure DevOps that says, here's the status of all of our services, so that you know if they're up or not and what regions they're in. We had that website hosted only in one region. Yep, that was the region. Struck by lightning, gone. We can't even tell you we're up a creek right now. Completely gone. What do we do now? That thing is replicated like crazy, right? That's the guy with the jack behind the guy with the jack, right? Because who would think that you're going to actually get struck by lightning and take down an entire data center? But every time something like that happens, when our air conditioners go off at a data center, it is unbelievable. Because those machines will literally melt themselves. I mean, that's not even a joke or an exaggeration. It's intense. So we learn hard lesson, you got to go back in and be prepared for everything. This is another one where I have to say, you want to make the red yellow and the yellow green, but you do not punish your team, right? Use this to inspect and adapt your process and make sure that it gets better. Some other things that I've kind of glossed over here, feature flags are something that we use quite heavily inside of our team. That's how we're able to mitigate problems so quickly. We do not believe in rollback. The reason why is because rolling back is hard, and upgrades should be easy. And the only reason you want to roll back is because the upgrade failed. So think about this for a second. Upgrades are easy, and you just screwed that up. But you think you can do the harder thing really fast and roll everything back and make it better. You usually make it worse, right? So we said, let's do this. Let's stop trying to do the hard thing and just completely eliminate it. So what we did is we started implementing feature flags. Every new feature is actually behind a feature flag, such that if we were to deploy that feature out and something bad happens, do we have to roll it back to turn it off? No. We literally just flip a bit. Feature goes off, system is mitigated. We can now go back in and do root cause analysis because we haven't contaminated the crime scene. We actually go back in and push a fix, push it back out, turn the flag back on. Let our users use it. If it works, great. If not, turn the flag back off. Mitigation becomes flipping a bit. Now, feature flags are not some panacea. They're not some amazing unicorn that craps Skittles or anything. It's technical debt, right? You have to think about this. It is a cost to having them, but it is a cost that we happily pay because the cost of not having them is way, way too high, right? So feature flags are something that we do a lot. Remember I talked about having to re-architect your system? Team Foundation Server, which is what we had on-prem, was lifted and shifted to the cloud as a monolith. We are now up to 30 microservices, basically satelliting that particular monolith. We've had to re-architect it because trying to ship a monolith every 3 weeks is a nightmare. Shipping microservices, much easier. But when you start to get to the number of 30, 40 microservices, the deployment starts to get complicated again because sometimes there's dependencies. Most times there are dependencies. And if the 4 of us are microservices and we all depend upon each other, the order in which we get deployed is important. And now all of a sudden our deployment becomes more complicated because it has to be orchestrated. But what if I could deploy the microservices in any order that I want, which means I could then also deploy them in parallel regardless of the dependency chain. But at runtime, the microservices are smart enough to negotiate the right version of the API to use such that we will never fail regardless if you're at the desired version that I want or not. How cool would that be? So we thought it was pretty cool too, so that's what we did. But we didn't just get that out of microservices. They just don't do that out of the box. You have to design that into the process so that we can deploy at the speeds in which we want it to deploy. And I only say that again because you've got to sometimes look at your solution itself and re-architect that to move at the speeds in which you want to move. Another thing that we had to do was stop having these enormous 20-person teams. We had to go back to much smaller teams, scrum teams that could do stand-ups in 15 minutes or less, that were completely vertically aligned on a particular feature so that they own the database, the middle tier, and the front end, reducing but not eliminating all the interactions that they had with other teams, so they had what we call aligned autonomy. Autonomy to do whatever you want. If you want to run your 3-week sprint like it's 3 one-week sprints, knock yourself out. If you want to do test-driven development or paired programming, we are not going to stop you. The only way we're going to align you is you better be ready to ship in 3 weeks. Aligned autonomy. They're adults. Treat them like adults. Let them go be great, and then just align them when you have to. And the last thing that I wanted to talk about here is the team room. Some teams, people love having their doors. They love being able to close it and have that privacy. But believe it or not, once you get used to being in a team room, you never not want to be in a team room again. It's a really productive and efficient way to work, and you'll get over the fact that you don't have a door. But this is just some of the stuff, and this is where we are so far. We're still learning at Microsoft. I hope to be telling this story for years, and it's changing over and over again as we get better at this, and we can share with you what we've done, and hopefully you can apply some of this with where you work as well. Now, I told you that we're really active on Twitter and that you can get a hold of my team whenever you need to. This is just a fraction of my team. These are the people that focus solely on DevOps. We got nicknamed the League of Extraordinary Cloud DevOps Advocates. It's a mouthful. And that hashtag would take up half your freaking tweet. So we came up with the other hashtag right there, which is LOECDA. If you use that hashtag in your tweet, not only will my team come running, several people at Microsoft will come running as well. It's almost like you're using a bat signal. And when you use it, we will all read it. And I will add people from our company to that tweet that can answer that question if we can't answer it ourselves. We will go write new documentation in docs.com. We will go write new startups for you. We will do whatever it takes to make sure that you are successful as our customer. If you do not have a Twitter account, just create one so that you can ask for help from us. It's an amazing way to get a hold of us. And you really will talk. If you send me an email, it can be weeks before I get to it. You send me a tweet, I will answer it as soon as I leave the stage. Right? So just to give you some idea of how dedicated we are to that. Again, if you need my Twitter handle, that's the quickest way to get it. This slide here is just some more resources that we have at Microsoft for you to use. The first show there, called DevOps Interviews, on the far right-hand side at the top, that is a show where I have sat down with engineers from inside of Microsoft who build Azure DevOps, and from anywhere from 35 minutes to 45 minutes, we simply chat about how we do safe deployment. Safe deployment is the practice where you actually deploy your code into several different production environments, one environment bigger than the next. And here, Manil Shah explains how we do that. We have 6 rings of deployment. Every 3 weeks, Azure DevOps wakes up and deploys itself on top of itself while the team is using it. Because ring 0 is the actual instance where the team works. We're the first team to get the changes that we want our customers to see, and we live with those changes for 48 hours before they ever see the light of day for anyone else. If we can't do our job on it, we'd never expect you to do your job on it either. So we have to live with that code for 48 hours. Again, quality goes through the roof because if I screw up, I take down 700 engineers. But if we do everything right, we're going to come to work, everything's going to work for 2 days, and then we're going to go ahead and give it to our MVPs, our RDs, and our what we call our friendly audience. So it's another production environment. This is not dev, QA, staging, prod. This is prod, 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 prod. Each prod getting bigger than the last, and we keep getting telemetry, feedback. We are testing in production, but because of feature flags and the other technologies that we have, rolling back and failing fast is something that we do really, really well. After another 24 hours with our friendly crowd, testing things that parts of the application that we don't test, we then finally give it to our Brazilian customers. They're the smallest production sample that we have. There we'll start to see if there's any performance issues in our telemetry, letting us know if it's running the speed it should be, now that's being hit by paying customers. And if that goes well, we keep on doing this. And it takes about 10 to 12 days to get it from ring 0 all the way out to ring 5, which is every customer in the world with the latest version of Azure DevOps, right? Now, sometimes you have to babysit those things a little bit, and he talks about that as well. We have something called a shield team. Of the 10 to 12 engineers that make up our Azure DevOps feature teams, 2 of them are going to be pulled aside during that release to make sure that that release goes successfully without having to incur any unplanned work that we no longer have capacity for because we booked everyone to full capacity and then something bad happened in our release. So those type of things we go into really deep detail in the show called DevOps Interviews. Underneath that is Azure Friday. That is just Scott Hanselman's show, so do not be shocked if you see me or Laura there. We are just guest hosts because Scott can't always make it to Seattle to record, but that show is fantastic for keeping up what's latest and greatest inside of Azure. Now below that, you're going to see the DevOps Lab hosted by Damian Brady, who happens to be here today and has a session, I believe, at 3 o'clock or 3:20, so you can actually go meet Damian and talk to him about his show, about some inside of DevOps, which are fantastic as well. Again, my name is Donovan Brown, and I am at Twitter if you need me. This is my first NDC, and now I understand why everyone says I needed to speak at NDC. This is a very cool format, and I just want to thank you so much for having me here. Thanks, everyone.